In this lesson, our goal is to kind of figure out what to do when we're given an equation and asked to graph it. We don't necessarily want to always go in and do an X and Y t-chart and just pick points and plug it in. Sometimes that can get really long depending on the intensity of the problem. So sometimes we want to be able just to be able to look at the equation and go, all right, if I can, from this equation, I can get this, 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 and this, put it all together and graph it. And that's kind of what this whole lesson was about, especially when those polynomials or the functions that you're looking at aren't just linear and quadratic. There's something higher, like you've got x cubes, x to the fifth in there. You're kind of wanting to see what you can do. So some very important information that you want to get when you're looking at the equation are the following. You always want to get the degree and the number of turning points. The x and y intercepts, of course, those are always so popular. When the graph is above and below the x-axis, and of course the end behavior. Okay, so let's take some of those information and let's go together and figure out what we can do with this first equation. Well, in this first equation, if you look at it, it doesn't look like the typical general form that we talked about in our notes. The general form being, you have the first term plus or minus the second term, all the way down. It goes in descending order to the constant. What this function actually is in terms of, it's in factored form, because we have quantity x minus 1 times x minus 3 squared times x minus 5. So it's in factored form. We can still get all the information. We just got to go about it. It's just a little bit different way. So the first thing they want us to find is the degree. Well, the degree always is like the maximum number of x-intercepts that we can get. Well, if we look here in factored form, this x minus 1, this parentheses is just to the first power. So it's telling me that I'm going to get at most one x-intercept from here. X minus 3 is being squared, which tells me I'm going to get at most two x-intercepts from here. And then x minus 5 to the first power, and that's telling me I'm going to get maybe at most once. So a total 1 plus 2 plus 1 gives me a degree of 4. Remember, turning points is always your degree minus 1, and that tells you when you're going to go from increasing to decreasing and back to increasing. And 4 minus 1, always subtract 1 from your degree to get the turning points, which is 3. So moving past that, we're going to find next is our x-intercepts. Well, because this function is in factored form, it's actually going to be really, really easy. We're going to set 0 for y, which in this case is f of x, is equal to x minus 1 times x minus 3 squared times x minus 5. So from there, just set each product equal to 0, just like we normally do. And because this x minus 3 is squared, what it's telling me really is I need to write this x minus 3 twice. And look right here. How many things did I write down? 1, 2, 3, 4. And look at our degree. Our degree is 4. It's telling us about our 4 x-intercepts. Now some of them repeat, but the maximum number is 4. So finish solving this out. We get x equals 1, x equals 3 twice, so we're going to call that a double root, and x equals 5. The next thing we have to find is our y-intercept, and our y-intercept is when we go up there and we plug 0 in for x. So 0 minus 1 times 0 minus 3 squared times 0 minus 5, or y is equal to negative 1 times negative 3 squared, which is 9, times negative 5. So negative, negative, positive will be a positive. 9 times 5 is 45. So we've got quite a large y-intercept, but we'll kind of estimate it when we get to our graph. Okay, so the next part they say is we want to know when is this graph above and below the x-axis. And we're going to start with a number line, and on that number line we want our x-intercepts. The reason why we want our x-intercepts and not our y is because above and below the x-axis are our x-intercepts. So on there we have 1, 3, and 5. And all we want to do is determine what's happening to the left, in between, and to the right of all these x-intercepts. So pick any number to the left. Let's start here on the left of 1. So any number to the left, let's say x equals 0. We want a number in between here, so between 1 and 3 would be like 2. Between 3 and 5 would be 4. And anything past 5, we can go 6, 7, 8. Let's just go small. Let's keep it 6. Alright, so each of these numbers that I have picked out in between and below or left and right of our x-intercepts, I'm going to test, and I'm going to test it back into the main function. And all I'm curious to find really is what's the sign that's coming out. Is this, when I plug in these numbers, are they going to come out positive or are they going to come out negative? That's all I really want to know. So if I plug a 0 back into our main function, I already know what comes out because that was our y-intercept. It comes out with 45, and 45 is a positive number, so I'm going to put plus right there. To pick a number between 1 and 3, we pick 2. And if I plug 2 back in the function, 2 minus 1 is 1. 2 minus 3 is negative, but since I'm squaring it, it's always going to come out positive. So I have positive from this front parentheses, positive in the second, and 2 minus 5 is negative. So positive times a negative comes out negative. So I'm going to put a negative right there. When I test 4, let's go back to the main function. 4 minus 1 is 3, it's positive. 4 minus 3 squared is always going to be positive because I'm squaring. So positive times a positive, and 4 minus 5 is negative. So overall, a positive times a negative is negative. All right, let's go to 6, last but not least. 6 minus 1 is positive. The middle term's always going to be positive. And 6 minus 5 is positive. So 3 positives make a positive. So putting this all together in a summary, I'm going to be above my x-axis everywhere to the left of 1. So that's what this far left positive is telling me, is that everywhere left, if I tested x equals 0, but I could have done negative 10, I could have done negative 20. What this is telling me is it's always going to come out positive. So I'm above, starting from negative infinity, going up to 1. I'm going to do a parentheses because I don't want to exactly include my x-intercepts, because at the x-intercepts I'm actually on the axis, and this is when I'm determining whether I'm above or below. So I'm going to say it all the way up to 1, and then again I pick right back up at the x-intercept of 5, and I'm going to go off to positive infinity. And then I'm below the x-axis everywhere from 1 to 3 and from 3 to 5. And again, I want to break this up because I don't want to include my x-intercepts as being above and below. Okay? And if you notice, all the numbers that are in here, when my intervals of above and below, are all my actual x-intercepts, 1, 3, and 5, and then other than that, it's infinities, and that's always going to happen. All right, the last thing they want us to find is the end behavior. And I'll do EB for end behavior. Some things we want to know is our degree. Well, and it would help also if I just spelled degree correctly. Our degree, in this case, is 4, so our degree is even. And then we also want to know is our leading coefficient. Well, our leading coefficient, is it positive or is it negative? So let's go to back to our original problem. If it was going to be negative, they would have to have put a negative sign right there. Maybe like either negative or like a negative 4 or negative 2. Well, since there's nothing there, we can consider it positive. So a degree that's even tells me that both ends have to be up. As I go off to infinity, both ends have to be up. Or down, I guess I should say. And the leading coefficient, because it's positive, tells me that both ends will be up. Okay, so putting this into kind of like that fancy notation, what it's saying is my y values will be increasing as I go left on that graph, and my y values will also be increasing or going up as I go forever right on that graph. Negative infinity going left, positive infinity going right, and the y values going up, y values going up. Okay, so let's put all this information together and actually give ourselves a good idea of what this graph is going to look like. So we have x-intercepts at 1, 3, and 5. We have a y-intercept way up here at 45, so I'm just going to kind of estimate it. My end behavior eventually says that after I'm done on the right passing that last x-intercept, I should eventually be up. And on my left side, after I'm done passing that left intercept, I should eventually be up. That's what the end behavior is all telling me. Now we're going to go to our sign chart to say what's happening in between all of that. Okay. Well, this part obviously tells me I'm going to go eventually up through that y-intercept. Okay. Now, at my x-intercept of 1, it says to the left of it, I've got to be above the x-axis, and to the right, I've got to be below. So as I'm coming from on the left, I'm above, and on the right, as I go past it, I'm going to be coming below. At my x-intercept here at 3, the left I should be below the x-axis, and then on the right side of it I should also be below. So what that's telling me is that I come up to touch or to hit that 3 right there. Instead of actually going through it, I'm not. I'm going to turn around and come back down. But that sign chart tells me that to the left and the right I've got to stay below. And then for our last x-intercept at 5, it says I'm going to start from the left, going below it, to the right I'm going to go above it. So I'm going to come down and then cross through and go back up. And if you look at that graph, I've got 1, 2, 3 turning points, which is great. A degree of 4, so 3 turning points. And this right here might not be the exact graph of our function, but it's a really good estimate of it. The only thing that might change is the fact of how low do those dips go. Are they even, or is one lower than the other? Things like that. So let's take these same thoughts and let's try it again for another example.